Welcome to the deep dive. Today we're tackling something huge in workplace safety, but maybe a bit hidden: materials handling.
Yeah, it really is. And the numbers are pretty stark.
Right. Get this. Materials handling causes something like 20 to 25% of all disabling occupational injuries.
A massive slice of the pie. It
Yeah.
touches almost every single industry.
Exactly. So, our mission today is to really dig into the hazards and, maybe more importantly, the controls for moving, lifting, storing stuff.
Uh-huh. We want to get past just knowing it's dangerous and understand the why and the how, the physics, the human side of it all.
So what's on the menu? We'll hit manual lifting, the everyday stuff,
Yeah.
then powered vehicles like forklifts.
Yep. And the big machines too, cranes, hoists, plus rigging at crucial connection point.
Oh yeah, rigging. And even conveyors and just, well, how things are stored.
And like you said, it's not just about listing the dangers, it's digging into why they're risky and crucially how we manage that risk, the science, the engineering behind it.
Right. The goal is for you listening to walk away with a real solid understanding. Actionable stuff.
Exactly. Insight, not just information.
Okay, let's jump into that first big one. Manual materials handling. This is where it gets personal, right? Because it involves, well, us.
Absolutely. And it's a huge source of injuries. Low back injuries alone, think about this, make up about a quarter of all workers' comp claims.
Wow. 1 in 4, just from lifting, basically.
Pretty much. And the main hazard, it's excessive force on the spine.
Okay, so it's not just about sheer weight, is it? You mentioned something about how you hold it.
Precisely. It's about the moment that's the rotational force the load creates on your back. Your muscles have to fight that.
Like holding something heavy close versus way out in front.
Exactly that. Hold it close, it's manageable. Hold that same weight out with straight arms. Suddenly it feels way heavier.
Right, because the moment, that leverage is much bigger.
That's it. And that put immense strain on your spine. Other big factors are, the size of the object, how often you lift it, and any twisting. Twisting is a killer for the back.
So how do we get a handle on this scientifically? It can't just be lift with your knees, right?
Well, that helps. But NIOSH, the National Institute for Occupational Safety and Health, they developed a lifting equation. It's a proper scientific tool to analyze lifting tasks. Okay, an equation. Sounds serious.
It is, but it's incredibly useful. It helps calculate the recommended weight limit, or RWL.
RWL.
Yeah.
Got it. What does that tell us?
It's the maximum weight that pretty much any healthy worker could lift repeatedly for a period without getting a higher risk of back injury.
Okay, so like a baseline safe weight?
Kind of, but it starts with the load constant, 51 pounds, and then multiplies it by several factors. These factors reduce that weight based on how far the load is from your body, how high or low the lift is, how often you do it, if you twist, even how good the hand grips are.
Ah, so it's dynamic. It accounts for the how, not just the what. Exactly. Then you compare the actual weight you're lifting to this RWL. That gives you the lifting index, or LI.
LI equals load weight divided by RWL.
You got it. And the key insight. If that LI number is greater than 1.0, the lift is considered hazardous. It needs redesign.
That's fascinating. It gives you a hard number. Moving beyond just feels heavy.
Right. It quantifies the risk based on the specific task, geometry, and frequency.
So thinking about everyday situations, maybe even at home, where might someone unknowingly push that LI over 1.0, even with something not obviously heavy?
Oh, easily. Think about repeatedly bending over to pick up, say, a stack of files or even small empty boxes that are placed far out in front of you on the floor.
Right, the reach.
Exactly. That reach, combined with doing it over and over, even if the individual box is light, that can quickly make the LI greater than 1.
Because the posture and the frequency multiply the risk.
Precisely. It's not just the absolute weight. It's the relative strain, the repetition. And that's why understanding this matters, whether you're shifting stuff at home or managing warehouse staff. A safe lift involves minimizing that moment, watching the frequency, avoiding awkward postures. It's more complex than just bending your knees.
Okay, so that's the human element. But sometimes the job is just too big for muscle power. That brings us to powered vehicles, like forklifts.
The industrial workhorses, yeah.
Yeah.
They solve the lifting problem, but definitely introduce their own set of pretty serious risks.
I can imagine. What are the big ones?
Well, with forklifts, rollovers are a major concern. Also, operators getting hit by falling loads from the forks.
Yeah.
Visibility is often poor around the vehicle, leading to collisions with people or structures. And crucially, stability.
Stability, how so?
A forklift's stability drops significantly when it's turning. or on any kind of slope, especially if the load is lifted high.
Ah, okay. The center of gravity shifts dramatically.
Exactly. It's a recipe for tipping over if the operator isn't properly trained and very careful.
So, how do we engineer safety into these machines? There must be specific features.
Oh, absolutely.
Yeah.
Key engineering controls are vital. You've got the ROPS, the rollover protection system. That's the cage or bar structure around the operator.
Right, you see those on tractors and things too.
Yep. And then there's the FOPS, falling object protection system. That's the overhead guard.
To stop things landing on the operator's head.
Basically, yes. And critically, seatbelts.
Seatbelts seem obvious, but how do they work with the ROPS specifically?
That's the key synergy. The ROPS creates a protective zone. The seatbelt keeps the operator inside that zone during a rollover.
Ah, so without the belt, the ROPS might not do much good if you get thrown out.
Precisely. You could still be crushed. The seatbelt is essential in conjunction with the ROPS. They work as a system.
That makes sense. So these aren't just nice-to-haves, they're engineered lifesavers for very specific high-risk situations.
Absolutely vital.
Are there common ways people maybe misunderstand or misuse these, like thinking they can jump clear?
That's a classic, dangerous myth, trying to jump clear. Almost always safer to stay put, belted in within the ROPS. Another issue is complacency. Maybe not wearing the belt because it slows speeds, or operating with damaged guards.
Thinking it won't happen to them.
Yeah, or just not fully appreciating how those systems are designed to work together. Bypassing safety features is never a good idea.
Okay, moving up in scale now. The real giants. Hoisting apparatus. Cranes, big hoists.
Yeah, the machines that literally build our cities.
But the risks must be equally huge. What can go wrong with these?
A lot, unfortunately. Structural failure from overloading is a big one. Tipping over if they're not set up on stable ground or if the load shifts.
That sounds catastrophic.
It is. And another major one, maybe less obvious, is electrocution from contacting overhead power lines.
Oh, wow, yeah. Didn't even think of that.
The potential for harm is just immense. Safe operation is incredibly complex. It needs meticulous planning, a highly trained, certified operator. You can't just hop in and go.
So what's the key tool for managing this complexity?
The load chart. Every crane has one, specific to that machine. It is the critical document.
The load chart. Okay, what does it tell you?
It specifies the crane's safe lifting capacity based on a whole bunch of factors. Things like how far the boom is extended,
The length, right.
the angle of the boom, how far the load is horizontally from the crane's center, that's the load radius, and whether the outriggers, those stabilizing legs, are deployed correctly. All these things drastically change how much the crane can safely lift.
So it's not one fixed number. It changes constantly with the setup.
Constantly. It's like the crane's dynamic safety manual for that specific lift. Modern cranes even have computers that monitor these variables and calculate the safe limit in real time, warning the operator.
That load chart sounds crucial.
Yeah.
But with all those variables, what's a common way operators might slip up when using it?
Often it's underestimating the impact of seemingly small changes. A slightly longer radius, a bit more boom angle, especially near the crane's limit, can slash the safe capacity.
Right, the margins get smaller.
Exactly. Or maybe not accurately knowing the total weight, including the rigging gear, hooks, everything, or not factoring in wind conditions. The chart and computer are tools. They still rely on accurate input and experienced judgment.
Okay, so the crane is powerful, the operator needs to be skilled, the load chart is key. But what actually connects the crane to the load? That's rigging, right?
That's rigging. Ropes, chains, slings, shackles. All the gear used to connect the hoisting equipment to the load itself.
And I guess that connection point is another potential failure spot.
Absolutely critical. Rigging failure is the main hazard here. It can happen from overloading the sling or chain, obviously,
Yeah.
but also from damage, wear and tear that wasn't caught, or just using it the wrong way.
So even a simple rope needs to be used correctly.
There's definitely a science to it. And one really important kind of counterintuitive thing is the sling angle effect.
Sling angle effect, what's
Well,
that?
Okay, imagine you're lifting something with two slings forming a V shape up to the crane hook. The wider that V gets, meaning the bigger the angle of each sling leg from the vertical, the more tension is put on each sling leg.
Wait, so wider angles mean more force on the slings, not less?
Exactly.
Okay.
Significantly more. If the angle gets too wide, say 60 degrees from vertical for each leg, the tension in each sling can be almost double the actual load weight it's supporting.
Wow. Okay, that's definitely counterintuitive.
It is. That's why selecting the right type of rigging, using it correctly for the load shape and weight, and inspecting it regularly for wear or damage is so incredibly important.
And how you attach it matters too, right? You mentioned hitches.
Yes, there are different ways to hitch the sling to the load. A simple vertical hitch is just one sling leg straight down. Easy, but all the weight is on that one leg.
Okay.
A choker hitch loops the sling around the load and hooks back onto itself. It grips the load, which can be good,
Mm-hmm.
but it often reduces the sling's capacity because of the tight bend.
Right, like kinking a rope weakens it.
Sort of, yeah. And then there's the basket hitch. The sling goes under the load, and both ends hook up to the crane. This usually shares the load between two sling legs.
And probably keeps the sling angles more vertical, reducing that extra tension.
Often, yes. If done right, it's generally a more stable and efficient way to lift suitable loads. It just highlights how much detail matters in every single connection.
Absolutely. Okay, one last area for today. Conveyors and storage. Maybe seems less dramatic than cranes, but still critical.
Definitely. Conveyors involve constant motion, so the big hazard is workers getting caught in moving parts. Belts, chains, rollers. Especially at pinch points or nip points where things come together.
Ouch. Yeah, I can picture that.
And also stuff falling off overhead conveyors onto people below. So the controls are pretty straightforward but essential. Guarding all those moving parts, those pinch points, and installing overhead protection like nets or shields where needed.
Makes sense. And what about storage? Things just sitting there seems safe enough.
You'd think so, but improperly stored materials are a major hazard. Things falling off shelves, entire stacks tipping over.
Right.
It raises that question. How often do we just walk past a stack of boxes or materials on a rack and not even think about the potential energy stored there, or the risk if it's not stable?
So what's often overlooked with storage safety?
Well, racks themselves have specific load limits and need to be installed correctly, anchored properly. But a subtle hazard is accumulated damage.
Damage, like from forklifts bumping into them?
Exactly. A little nudge here or scrape there.
Mm-hmm.
It might not look like much, but it weakens the rack structure over time. Regular inspection is crucial. Then there's how you stack things.
Like building blocks?
Kind of. Using proper techniques like cross-tying layers or stepping back upper layers like a pyramid makes the stack much more stable. Using the right racks for the weight and definitely protecting those rack columns from vehicle impacts with barriers or guards.
So even static storage needs active safety management.
Absolutely. It's a dynamic system, even if it looks still.
Wow. Okay, so we've covered a lot. From the strain on our own backs and manual lifting through forklifts, giant cranes, the physics of rigging, and even the dangers in conveyors and storage.
Yeah, it really shows the breadth of materials handling. But also the systematic approach needed for safety, understanding the forces, engineering the controls, training people properly.
It's this blend, isn't it? Biomechanics, engineering, training, and just constant vigilance.
Exactly. Knowledge is absolutely key. Understanding these principles is paramount to preventing injuries, keeping things moving efficiently, and honestly, just keeping people safe.
So as we wrap up, here's a thought for you, the listener, to take away. We started with that big number, 20–25% of disabling injuries. Given how complex yet often invisible these systems are, what role does our own individual awareness and maybe our collective responsibility play in bringing that number down in our workplaces, even in our daily lives? What unseen hazards in how things are moved or stored might you notice now that perhaps you didn't before?
Yeah, something to think about. What might be lurking right under our noses?
It's definitely food for thought. Join us next time for another deep dive.